Introducing M2.
4, count them, 4 Avalanche high-performance cores, 4 Blizzard high-efficiency cores, up to 10 G14 graphics cores, 16 5th-generation neural engine cores. But we're increasingly living in a post-big core world, so tack on a new Secure Enclave, an expanded video encode and decode blocks, including hardware acceleration for 8K ProRes video, basically increasing performance while preserving battery life and kicking off just the next generation of Apple Silicon Macs. It's M2, and like M1, it's an SoC, or system on a chip. And that just means that all of the components, like the CPU and GPU and the memory, they aren't laid out on a board in the usual way, like a nigiri platter, but instead they're all rolled up into a single die, like maki. And that comes with the cost of modularity, which we'll get back to in a hot multiple display support minute. But it does provide incredible value in terms of economy and performance efficiency, which is gonna be pretty much the theme for today. Apologies, I'm losing my voice a little. Dub DC, but please bear with me.
It began with M1's breakthrough set of features that transformed our most popular systems. M2 starts the second generation of M-series chips and goes beyond the remarkable features of M1.
So, in broad strokes, it's the Bionic-style architecture that we've seen from Apple since the A11, more specifically, the extended version, the one that we've seen since the A12X, all designed to deliver exactly what Apple needs for each and every device up and down the lineup, without falling into the trap of a merchant silicon provider by turning each of those devices into a unique and separate client. From just two A13 generation cores in the Apple Watch to 20 A14 generation cores in the Mac Studio Ultra, and now 8 A15 generation cores in the upcoming MacBook Air. It's what Apple calls their scalable system architecture, and to do that, each year, every year, Apple's head of platform technologies, Johnny Cerrugi, sits down with the head of hardware, John Turnus, the head of software, Craig Federighi, and they scope out what they'll need to deliver based on extensive input from Greg Joswiak, Jaws's product marketing team. Not for that year though, but for 3 years out down the line. And while it does sometimes have its downsides, like maybe HDMI 2.1 isn't ready for prime time when they spec'd it out 3 years ahead, but it's also let Apple drop bombshell after bombshell on the industry.
A7 is 64-bit. There's a new Apple-designed performance controller that in real time makes sure the correct processes are running for maximum performance or maximum battery life. We built Apple's first ever neural engine. Yeah, this is a big deal.
Our first chip designed specifically for the Mac. And we call it M1.
All told, it'll have taken around 20 months to go from the first M1, the one that shipped back in November of 2020, to the first M2, the one that's shipping in July of 2022. And that's nowhere nearly as fast as Apple's decades-long streak of yearly A-series updates. But one update does not allow us a pattern to infer, and Apple's old AX series updates ranged from 6 months from the A5X to the A6X to 16 months from the A10X to the A12X. So it could end up being just as simple as expect new M-series SoCs when you see them, especially because Apple probably won't be shipping one SoC each cycle, but a whole family of base, Pro, Max, Ultra, and maybe one day even more. Where M1 was the same IP generation as the A14, M2 is the same IP generation as the A15. And I mean, absolutely no surprise to anyone who subscribes to this channel because, yeah.
I think we've nailed it.
But also like M1, M2 takes that IP into a whole new chipset direction, starting with transistor count, where M1 had 16 billion transistors, M2 has 20 billion. And since the second generation 5nm process Apple is using, which is almost certainly Taiwan Semiconductor's N5P, doesn't do much, if anything, to improve transistor density, that probably means M2 is also slightly physically bigger than M1, which is just exactly what Apple was showing off during the announcement.
M2 features our next generation CPU.
We're moving from the A14 and M1 generation Song of Ice and Firestorm efficiency and performance cores to A15 and now M2's all in on the cold Blizzard and Avalanche efficiency and performance cores, and these are ARM64 cores. But Apple has an instruction set architecture, or ISA license, to the extent that they can pretty much do whatever they want with it, and that's beyond ARM64 basically being an Apple-driven ISA to begin with. And yeah, there's still no evidence of Apple adopting anything from ARM's new V9 ISA, which is also honestly exactly what we expected, because V9 has always seemed to be more about ARM trying to deliver everything Apple's done since V8 to their other licensees. In other words, almost pure catch-up. While I'm sure some people would love things like V9 hypervisor compatibility, the only thing that I think is purely empirically, legitimately interesting to everybody is the new matrix multipliers, the new vector units. And I'm guessing Apple will just fold that in along the way at some point anyway.
We've increased the performance of our CPU's dedicated machine learning accelerators that power experiences such as advanced text-to-speech in Siri.
Apple hasn't said anything about frequencies, as is their wont. I mean, outside.
With an active cooling system, the MacBook Pro is designed to sustain its pro performance.
But usually, the bigger thermal envelopes of laptops over phones means Apple is comfortable letting the cores run just a little faster inside them. Like with M1, where the iStorm efficiency cores, or E-cores, went up from 1.8 gigahertz to 2 gigahertz, and the Firestorm performance cores, or P-cores, went up from 3 gigahertz to 3.2 gigahertz. But Apple has also said that if it ever comes down to a choice between a few percentage points for top right Mac's position on some perf chart and a substantive increase in battery life for users, they'll choose the extra battery life each day, every day of the week. So at barest metal minimum, the Blizzard E-cores will be at the same 2 gigahertz and the Avalanche P-cores will be at the same 3.2 gigahertz, not just because of the M1, but because that's what the A15 was already, which also makes it entirely possible that they could max just a tiny bit up to 2.2 and 3.4 gigahertz respectively. We'll have to wait for a Nantec or the like to know for sure if there's even anyone left at a Nantec by then, because please just fund those people up already, would you? And if you're upset they're not even faster than that, just remember what Johnny Sarugi said on stage.
Unlike others in the industry who significantly increase power to gain performance, our approach is different.
Apple's simply not willing to goose power draw in order to win some meaningless benchmark LARP crown from YouTube or Reddit, not when it comes to destroying battery life or forcing massive noisy enclosures or having to ramp base frequencies down as the core count goes up. I mean, Intel and Nvidia are getting to the point where you can't even put them both on the same residential outlet anymore without blowing a fuse, and forcing people to find separate circuits for their PC build is just not a realistic consumer solution, which also means a little out of bounds for M2, but that's also why M1 scaled so well. With Intel, as core count went up, base frequencies went down. That's why the i9 iMac had way faster single core than the Xeon iMac Pro, why Xeon in general had way slower single core. Apple doesn't have that problem with their silicon. Their performance per watt is so good that they can double the core count and base frequencies stay exactly the same. And that is the big deal. But when I'll talk about more as M2 starts being scaled up and out.
When we look at the multi-core CPU performance of M2 compared to M1, it delivers 18% greater performance.
Some of the performance improvements come down to the frequency increases. The N5P node also gives about a 5% bonus.
And twice the system cache.
From 16 to a whopping 32 megabytes, and the P-cores specifically increased the L2 cache from 8 to 12 megabytes. M2 raises the shared cache from 12 to 16 megabytes, which meant on A15, P-core performance went up between 2.5% to over 37%, depending on the type and latency of the workload. And that's with efficiency increases of like 8% to 24%, even with those increased performance levels. E-core performance, though, went up 28%, which is staggering, not only in its own right, but in that it means the P-cores have to engage even less frequently than before, leading to even more efficiency increases, though it's probably worth debating if it's even fair still calling those things E-cores anymore, given their now ludicrous levels of performance?
M2 delivers up to 25% higher graphics performance at the same power level as M1, and up to 35% higher performance at its max.
Just like the iPhone 13 Pro got 5 graphics cores instead of just 4, M2 now goes all the way to 10 cores, not just 8. They're the same G14 cores, at least I think that's what they're called now, using Apple's AGX architecture. But in this case, Apple is willing to let those cores run just ever so slightly hotter. There's also a larger L2 cache, though what larger is in this case, still undefined, all of which makes it hard to interrogate exactly what the actual core-over-core increases are, just that they are. But outside intense nerd interest like mine, it doesn't matter as much for a Mac as it does for an iPhone, because in the tiny thermal envelope of an iPhone, the extra power or core can result in far more aggressive throttling, where on the bigger thermal envelope of even a MacBook Air, that throttling can be way less aggressive, and depending if there is a redesign or not, maybe much less or even non-existent when we get to an M2 Mac Mini at some point down the line. Of course, there's nothing in the way of ray tracing support yet, which is just the latest battleground in PC gaming, and maybe something Apple will address in the future, but G14 does add support for lossy texture compression. G11 previously added lossless support, but lossy means half the memory for the same resolution texture, or better still, double the resolution for the same memory.
The neural engine in M2 can process up to 15.8 trillion operations per second. That's over 40% more than M1.
The ANE, or Apple Neural Engine cores, are faster as well. There's still 16 of those cores, but it's almost impossible to figure out why they're faster beyond some possible combination of architectural and frequency improvements.
It also has our next generation media engine, including a higher bandwidth video decoder that supports 8K H.264 and HEVC video. And M2 features our powerful ProRes video engine for hardware-accelerated encode and decode.
Back in 2019, Apple offered a reprogrammable ASIC card named Afterburner for the then new Mac Pro. It was basically just dedicated silicon for ProRes acceleration. But fast forward to September of 2021, and Apple managed to PIM particle all of that tech down into encode and decode blocks right on the A15 die, which is what let it handle ProRes 422 HQ HDR video recording and playback on an iPhone. Skip ahead to October of the same year, and Apple put versions of those blocks on the M1 Pro and even more of them on the M1 Max, making them not just faster when it came to ProRes rendering, but getting the process just entirely off the CPU. So unlike an Intel Mac, where rendering ProRes was so CPU intensive, you could barely surf the web at the same time, on an M1 Pro or Max or Ultra, the CPU is free for you to use for anything else, even another heavy app like Photoshop. It's effectively like having 2 Macs to use at the exact same time, one busily off rendering and the other just completely ready and available to you. And now that same ability, that same capability is built right into the M2 non-Pro, non-Max, non-Ultra as well, just plain M2. So we can conceivably, will be able to conceivably do much higher end video work, never mind on a MacBook Pro, but on a MacBook Air soon as well. Because M2 can handle 2 8K streams and 11 4K streams, where M1 Pro can handle 4 8K streams and 20 4K streams. The Secure Enclave, which handles Touch ID, real-time encryption, and more, has also been updated for M2, so it may be some combination of faster, more efficient, or just plain better at its job. But the larger point is that Apple clicks every part of the IP forward every year. They touch every transistor. There may be bigger boosts some years than others due to things like process node shrinks or specific architectural advancements or new dedicated silicon IP. But either way, anyway, it's just nothing like Intel's classic tick-tock cycle or its current tick-tock optimize cycle. No one on the silicon team gets to take a year off. Everyone and everything has to contribute towards the overall efficiency and performance improvements every year, which are so damn relentless because everyone and everything has to contribute towards them every year. That's literally their whole entire one and only job, each year, every year, to push Apple Silicon further and further to run Apple software faster and faster, given only the limits of time and the thermal envelope of the device, of the physics. But where M2 doesn't push forward is in ports and display support. You get 2 USB controllers and 2 Thunderbolt controllers, and they support exactly what M1 supported, USB 4 and Thunderbolt 3. Why Thunderbolt 3 like M1 and not Thunderbolt 4 like M1 Pro, Max, and Ultra? Well, because Thunderbolt 4 requires dual external display support, and Apple is only offering single external display support, so it can only be certified as Thunderbolt 3. And this won't matter at all to the vast majority of people, since the vast majority of people don't even use a single external display, never mind 2, but it will matter a lot to the nerds, meaning everyone on tech YouTube, everyone on tech Twitter, who do want to plug in multiple external displays because they want to cram themselves into an M2 MacBook Air while they wait on the inevitable M2 MacBook Pro that will in fact support all of the displays. But unlike PC merchant silicon vendors who just never know what their chips are going to end up in, and so have to support far wider specs on each and every version of each and every chip, Apple makes specific chips for specific machines, and the MacBook Air is meant to be a very, very mainstream machine. So if anything has to be sacrificed in the name of cost or efficiency or whatever, it's going to be features that Apple believes are mainly for the pros. Now, the image signal processor, or ISP, is also new and A15 generation, and that might not matter to you as much on a Mac as it does on an iPhone because of the massive disparity in the cameras between those two products. But it will be better, it will be faster, and it'll absolutely help with the new 1080p MacBook Air webcam, for example. But what will absolutely matter to you is that feeding all these compute and dedicated silicon engines is a new memory system.
For M2, we've enabled up to 24 GB of unified memory, starting with the memory controller, which delivers 100 GB per second of unified memory bandwidth, which is 50% more than M1.
Where M1 was still using LPDDR4 and was limited to 16 GB of memory at 70 gigabits per second, M2 now uses LPDDR5, like the M1 Pro and M1 Max and Ultra, which means even as an ultra-low power part, it can support up to 24 gigabytes of memory at 100 gigabits per second, which, side effect, having everything on LP5 now means the lineup is just super neat. 100, 200, 400, 800, doubling from base to Pro to Max to Ultra with the bandwidth right across the line. But it's also still in 2 stacks on package, not 3. Apple's just splitting it differently. Instead of 8 and 8 for the 16 gigabyte model, they're using 12 and 12 for the 24 gigabyte model for the highest end config. But it does mean there's even more memory available for people who really want to try and push heavy workloads on the go. All of that to say, unified memory is amazing. It means you get all of that RAM, not just to the CPU, but to the GPU and the other engines, but you also get all of that memory bandwidth, not just to the GPU, but to the CPU and also all of the other engines, combined with the M series, just excellent memory compression and super fast storage controller and SSD speeds for swap. And there's still nothing magic about it. 8 gigabytes is still 8 gigabytes. It doesn't become 16 gigabytes, but that 8 gigabytes, that 16 gigabytes, and now that 24 gigabytes, it can all just really be absolutely all that it can really be. Like you can be part of the future of Apple Silicon or software or both with the computer science, neural networking, machine learning, and algorithm courses from today's sponsor, Brilliant. Brilliant is the online interactive STEM learning platform with a growing catalog of courses, including also math, physics, logic, science, quantum mechanics, game theory, and so much more, all specifically crafted to help you learn concepts by working through them yourself in visual, hands-on ways. Like if you wanted to learn to code but were put off by overly complicated traditional computer programming courses, Brilliant has real, fun, interactive challenges that let you shift blocks of pseudocode around, receive immediate feedback, and get results. You feel like you're solving puzzles, gaming even, but the whole entire time, you're learning how algorithms work, And once you know that, coding becomes just way less intimidating and way more accessible and fun. Because here's the thing, here's the secret. Everyone starts somewhere, and you can get started right now, today, for free. Just visit brilliant.org/Ritchie or click the link in the description. And the first 200 people will get 20% off Brilliant's annual premium subscription. Just click the button on the screen or go to brilliant.org/Ritchie. Clicking on that button really helps out the channel. And so does hitting up this video for way more on the history of Apple Silicon and how Apple has been iterating on it for a decade and a half now. So just hit up that video and I'll see you there.